Today we're going to be talking about Kubernetes. Now, Kubernetes help you manage and organize containerized application, making it more reliable and easier to maintain. When we talk about Kubernetes, it is very important actually to talk about containers. So containers are self-contained unit of software that package up everything an application needs to run. Code, library, and settings. Think of them as individual shipping containers. Think of it this way. Imagine you are managing a bunch of small plants in your garden. Each plant needs water, sunlight, and care. Now, imagine you have so much plants and it's very difficult for you to keep track of each plant individually. Kubernetes is like a smart garden that manages all these plants efficiently. It automates tasks like watering, making sure that your plants get everything they need without doing it manually. So in simple terms, Kubernetes is like a helpful gardener that helps you manage all the software applications, which we call the containers, and making sure they run smoothly on a bunch of computers. So what are the benefits of using Kubernetes? Easy deployment and scaling. You can easily deploy and scale your application. High availability. If a container fails, Kubernetes can help restart it automatically, making sure that it's up and running. Portability. Applications built with Kubernetes can run on different cloud platforms. When talking about Kubernetes, it's also important to understand what is a cluster. Think of a cluster like a group of friends hanging out together. Each friend have their own unique skills and interests, but they come together to achieve a common goal or have fun. In the world of computing, a cluster is a group of computers that we call the servers that come together to work as a team. Each computer in a cluster, just like each friend in a group, come together to contribute certain resources like processing power, memory, and storage to help accomplish a certain task or run software application more efficiently. They collaborate and share the workload, making it easier to manage a large task or handle them more quickly than a single computer could manage alone. So a cluster is basically a team of computers coming together to perform a certain task. As we talk about Kubernetes, it's very important to understand what are nodes. In the analogy of friends forming a group, think of a node as a single friend and a cluster as a group of friends. So, a cluster is made up of multiple nodes. Each node is like a member of the group, contributing its own resources and capability to the cluster's collective power. Just as a friend in a group have different skills and capabilities, node in a cluster might have different specification or roles. For example, one node might be responsible for processing data, another for handling files, and another for handling network communication. Together, these nodes work in harmony within the cluster, each playing its part to achieve the cluster's goal, whether that's running software application, handling user requests, or processing data tasks. When talking about a cluster, we must understand what is a master node and what is a worker node. A master node is the brain of the cluster, and a worker node is where the heavy lifting, like running your application, happens. In a cluster, there are 3 nodes. 1 is the master node and 3 work nodes. A master node is like the boss of the Kubernetes cluster. It's in charge of making decisions and managing the overall operation of the cluster. Now, inside the master node, there's something that is called the control plane, which has the important components that control how a cluster works. So we have the API server, This is where you send a request to tell the cluster what to do. Scheduler. Think of the scheduler as the organizer. It decides which computer in the cluster should run each task. Next is the cluster store. This is like the memory bank of the cluster. It stores all the important information about what's happening. Next is the control manager. The control manager is like the task master. It keeps an eye on everything that is happening in the cluster and makes sure everything is running smoothly according to the rules you have set. Next is the cloud control manager. If your cluster is running on cloud provider like AWS and Google Cloud, the cloud control manager helps the cluster communicate with cloud provider service and resources. Now this is something you should note. The master node and the control plane components work together to keep each Kubernetes cluster working and running smoothly. Now, let's talk about the work node. So work nodes are either virtual machines or physical machines that run the Linux operating system. They provide the execution environment for your application, allowing them to run smoothly within the container. So here we have the node, then the pods are now what we call the containers or the applications or the microservices. Now, in worker node, we have three components. We have the kubelet, we have the container runtime, and we also have the kube proxy. This is inside the work node. Now, let's talk about kubelet. Now, the kubelet serves as the primary agent running on every node within the Kubernetes cluster. It receives pods definitions from the API servers and interact with the containers runtime to execute containers associated with each pod. Additionally, it reports the states of both nodes and pods to the master node through the API. Now let's talk about the container runtime. Now, the container runtime is responsible for pulling images from Docker. Now, the container runtime is responsible for pulling images from Docker, GCI, ECR, or ACR. Kube proxy is an agent that runs on every node through daemon set. It's responsible for managing local cluster networking, assigning each node its own unique API address, routing network traffic to the load balancer. Now let's talk about facts of pods. Each pods are located within the nodes. Each pod contains a group of one or more containers. They represent a running process. Pods share networks and volumes. Pods never create themselves. Instead, controllers are used for their creation. How do you run Kubernetes? Now, one thing you have to understand, Kubernetes is managed by EKS, which stands for Elastic Kubernetes Service from AWS, Google Kubernetes Engine from Google Cloud, AKS, Azure Kubernetes Service from Azure, and any other cloud providers. Running Kubernetes locally involves several options, including Minikube, Kind, and Docker. But for this, we're gonna be using Minikube because of several strong points. Number one, it has a vibrant community, abundant add-on and features, and comprehensive documentation. Now, to set up the environment, we need to install Docker and Minikube. In order to understand how to work with Kubernetes, click on my next video to follow up this course.